All right, guys. Welcome to uh, Muppet Baby World. Hey, we get to make stuff up today, and I really like talking about imaginary numbers because the way this came around, literally, we just made it up. Something wasn't allowed. Something didn't work in math, so we invented a number so that we could say that it does work. And so here's what happens. If you use your calculator to evaluate root negative 16, so if I try to take the square root of negative 16, I end up with an error, and it says non-real answers. So I plug this in, I get an error because if you remember, the square root means two numbers that multiply together, two of the same number that multiply together to equal negative 16. Well, if I use two positive numbers multiplied together, I get a positive. If I use two negatives, I get a negative. There is no way to multiply the same number by itself and to end up with a negative. So you can't take the square root of a negative. You can't do it. It doesn't work. And so this started to create some problems because we really wanted to keep going in math and we really wanted to keep working with these numbers, but it wouldn't let us. So we decided to invent a number. And the number that we invented the number square root of negative 1. And it has a name, and it's called I. Okay? The square root of negative 1 is called I, and it is an imaginary number. It's called a complex number because it doesn't actually exist. We use it to do math, but it's not a real number. In fact, there's no such thing in the real world that would do what this imaginary I number does. So, for example, this square root of negative 16, what I do is I change that to the square root of 16 multiplied by the square root of negative 1. So I factor negative 16 into the 16 and the negative 1. Well, that just equals the square root of 16 is 4. The square root of negative 1 is our imaginary number I. So the square root of negative 16 is 4I. The I tells you that there's this imaginary square root negative 1 number attached to the 4. Okay? So square root of negative 8, I can split that up to be the square root of positive 8 times the square root of negative 1. Now, the square root of 8 doesn't give us a nice number, but remember, we can factor that to be 4 times 2, and then that to be 2 times 2. So this one actually becomes the square root of 2 times 2 times 2 times the square root of negative 1. Well, this is a square root, so I'm looking for groups of 2 to pull out. And I have a group of 2 right there, so I can pull the 2 out front. I'm left with a 2 on the inside, and my square root of negative 1 is my I. So the square root of negative 8 is 2 root 2 I. The square root of negative 25, well, that's just square root of 25 times square root of negative 1, which is 5I. This is my 5. This is my I. Okay? Square root of negative 48, again, that becomes the square root of 48 times the square root of negative 1. The 48 we can split up into 16 times 3. And I know the square root of 16. It's 4. So my answer becomes 4 square root 3 times I. So 4 root 3 I would be my answer. Now, dealing with I, we've got to be just a little bit careful because weird stuff happens. I itself is just the square root of negative 1. Okay, so I is equal to the square root of negative 1. I squared means the square root of negative 1 times the square root of negative 1, which is just equal to negative 1, because I'm taking the root times the root of the same thing. I cubed is the square root of negative 1 times the square root of negative 1 times the square root of negative 1, which equals my I squared, negative 1 times the square root of negative 1. So this becomes negative I, because this is I and this is negative 1. So I cubed is negative I, and I is just square root negative 1, which we'll just keep calling I. So let's put this here as well, the negative root of negative 1. And then I to the fourth is root negative 1 times root negative 1 times root negative 1 times root negative 1, which is just two of these. It's just negative 1 times negative 1, and I get positive 1. So I to the fourth is positive 1. Now this pattern repeats. If I were to look for I to the fifth power, I would start back over right here. And then I to the sixth would take me right here. Then I to the seventh would take me here. I to the eighth would take me here. Okay. So to figure this out, basically what we need to do, if I was looking for I to the 13th, I need to subtract 4 until I get all the way down to either 1, 2, 3, or 4. So I need to do 13 minus 4, which is 9, minus 4, which is 5, minus 4, which is 1. So really, I to the 13th is the same as I to the first power, which is just I. Okay. I to the 20th, if I do 20 minus 4, I get 16 minus 4. I get 12 minus 4. I get 8 minus 4. I get 4. So I to the 20th is going to be the same as I to the fourth, which is going to equal 1. Okay. Now, I to the 42, we're going to do 42 minus 4 and get 38. And then we're going to just keep counting down. I'm going to go 34, 30, 26, 22, 18, 14, 10, 6, and 2. So I to the 42nd is the same as I squared, which is negative 1. All right. Now, I don't know if we'll actually do this on the test, but this right here likes to come up on the ACT. They like to throw in problems with I like that one. Now, what if I try to add these together? So 5 plus 3i plus 6 plus 7i. Well, this plus just makes this become 5 plus 3i plus 6 plus 7i. And we can treat I just like combining any other like terms. Okay? We're going to treat that I just like any other term. So the 5 and the 6 are going to add together and become 11. The 3i and the 7i are going to add up to be 10i. Okay, same with subtraction. I've got 12 minus 100i, but this subtraction, be careful, don't forget to distribute that. That becomes minus 15 and minus 99i. So 12 minus 15 is negative 3. Negative 100 minus 99 is negative 199i. So that would be my final answer. And we usually put the normal number first and then the number with the I second. Okay. Now, what if we have to multiply? Right here, we have a situation where we either have to do FOIL or we have to do the box. I'm going to go ahead and do the box right here because I want to show you something kind of cool about these I problems. If I put 2 and negative 3i across the top and 5 and 7i right here, 5 times 2 is 10. 5 times negative 3i is negative 15i. 7i times 2 is 14i. And 7i times negative 3, that's negative 21. But I times I is I squared. Now, before I start writing these down, that I squared creates an interesting change here. Remember back on our last slide, I squared is actually equal to a negative 1. So this negative 21i squared, negative 21i squared is actually negative 21 times negative 1, which is just positive 22. So that I can change to a positive 22. Wow, Mr. Reed, bad math. Positive 21 I don't know what I'm adding to what. The negative times a negative makes it a positive. So I get a positive 21 right here. Now, these two can now go together because this is 10 and this is 21. So I get 31. And this 14i and this negative 15i just becomes negative 1i. So my answer is just 31 minus I. So when you multiply two complex numbers together, you end up with another complex number. You don't end up with an I squared. Well, you do. It just cancels away. Root negative 6 times root negative 15. So this just becomes root 6 times root 15 times I from this one times another I from this one. Root I. Or root I, square root negative 1, square root negative 1. I'm working ahead of myself a little bit here. Well, the square root of negative 1 is I. The square root of negative 1 is I. So I have I times I, which is I squared, which we just decided was negative 1. Okay, that's interesting. Root 6 times root 15 is root 6 times 15. And this factors to 2 times 3. This factors to 3 times 5. So I get root 2 times 3 times 3 times 5. These two 3's pull out front. So I end up with a 3 in front. I'm left with 2 times 5 on the inside. And this I times I, this I squared, just becomes a negative 1. So my answer actually just becomes negative 3 root 10. When I multiply my i's together, they go away. So when I multiply those two negatives, I end up with a negative number. It's kind of cool. Now, what we really want to know, you've just been waiting and just, come on, Mr. Reed, get to it. I want to see quadratic formula with I in it because you told us last time we're going to use it. Well, here we go. X squared plus 4x plus 8. Quadratic formula says x equals, here's my A, here's my B, here's my C. Opposite of B, so negative 4, plus or minus the square root of 4 squared minus 4 times A, which is 1, times C, which is 8, all divided by, whoa, don't do that, all divided by 2 times 1. Must be getting late or something. Negative 4 plus or minus square root. Let's plug this part in the calculator. So 4 squared minus 4 times 1 times 8 is going to give me a negative 16. So I've got negative 16 underneath and 2 on the bottom. Well, that negative 16, I can rewrite that. Negative 4 plus or minus. Remember, negative, this part right here can become root 16 times root negative 1, which is the root of 16 is 4. The root of negative 1 is I. So this becomes 4 I on top divided by 2. So here we can split it up if we want. I'm not going to quite split it up yet because this has a 4, this has a 4, this has a 2, which means both of those can reduce by a factor of 2. So negative 4 divided by 2 is negative 2, plus or minus. 4 divided by 2 is 2, but I still have an I. So my answers, x equals negative 2 minus 2i and negative 2 plus 2i. So now I can come up with imaginary answers. They're still not real. There is no negative 2 minus 2i on the x-axis. This is still not going to cross the x-axis. But we have imaginary numbers, which later this year, we're going to use to do some pretty cool math. Couple more examples. Let's set this equal to 0. And let's say there's my A, there's my B, there's my C. So x equals negative 3, the opposite of positive 3, plus or minus the square root of 3 squared minus 4 times 5 times 3, all divided by 2 times 5. So that simplifies to be -3 plus or minus the square root. Let's plug that in my calculator here. 3 squared minus 4 times 5 times 3 gives me the square root of -51, all divided by 10. Now, -51 is not prime. 51 is divisible by 17 and 3. But those are both prime. So we're not going to be able to pull anything out other than I can rewrite this as -3 plus or minus, instead of a negative square root, because we're not supposed to do that, I can change that to root 51 I, all divided by 10. So my answers, with all this space that I have, holy smokes, -3 plus root 51 I. The I is outside the root, guys. Don't put it underneath. Divided by 10. And -3 minus root 51 with an I outside over 10. Okay, if you're worried about that I getting mixed up underneath, you can always put it in front of the root. You can put I root 51. That's an acceptable answer as well. Okay, so if you've got the hang of this, if you're ready to try it on your own, go ahead and pause the video. I'm going to do a couple more examples for the rest of you, but you can pause the video right there if you would like to work on, we're doing homework 10C. We're going to work on that at home, get as much as you can done at home, come to class with questions, and we'll do the 10AB in class. All right. For the rest of you that want to stick around and see a couple more examples, let's try the quadratic formula. So x equals, here's my A, here's my B, here's my C. The opposite of B, so this is going to be a +5 plus or minus square root of -5 squared minus 4 times 5, all divided by 2 times A, which is 4. So when I rewrite 5 plus or minus, 8 goes on the bottom, and I'm going to get the square root of, let's see, -5 squared minus 4 times 4 times 5, which is -55. Now, -55 factors to 5 and 11, which are both prime. So I'm going to go ahead and leave it the way it is, other than I want to write this as 5 plus or minus, instead of root -55, I'm going to put root 55 times I, all over 8. So x, my answers are 5 plus, let's put the I in front, I root 55 divided by 8, and 5 minus I root 55 divided by 8. Those would be my two imaginary solutions. So remember, it will not cross the x-axis, but we do have imaginary answers, just not real ones. I wish all math could be done that way. You could just make up a rule, pretend a number existed, and then say, here's my imaginary answer, give me credit. But it doesn't work that way. So here's A, here's B, here's C. So x equals the opposite of B, so +1. I guess I don't need to put a plus. Plus or minus square root, -1 squared minus 4 times A times C, all divided by 2 times A. So this becomes 1 plus or minus square root of something over 4. So let's put that something in our calculator. -1 squared minus 4 times 2 times 1. And I'm going to get -7. Now, -7 definitely doesn't factor. We're not going to make that a nice, pretty root. So my answers, I'm just going to change this to 1 plus or minus I root 7 over 4. So x equals 1 plus I root 7 over 4 and 1 minus I root 7 over 4. Those would be my two imaginary answers.